for the first day back. So growth and decay equation is a specific type of separable differential equations. It's just they happen so frequently, we take a couple days to look at them specifically. So sort of we know how to do these, sort of. In this section, we'll create and solve differential equation which describe the rate of growth or decay of a function in a situation. So the solving part, this is stuff we've already done. Creating is maybe the new part. So before they just gave us the equation to work with. Today they're going to give us a statement, and so we got to work on this first part is sort of translating English to math. All right, like going from words to an equation. That's the new part. Words to equations. Once we have an equation, then in theory we know how to solve it, but this will just be more practice for the solving part. Okay, to do this, first we need to recall the concept of proportionality, meaning the statement y is proportional to x. Do you remember how to write an equation that means
the colon?
Y is proportional to x?
Y is to x is x is to y.
No, it's an equation. It has a k in there.
What?
You haven't done this in, I think my 7th grader was doing this last semester. Obviously not the calculus part, but talking about proportional. K is the constant of proportionality. Fancy talk there. Constant of proportionality. And the idea is if x doubles, then y doubles. If x triples, y triples, regardless of what k is.
Yeah.
So they remain proportional.
So basically it's a linear equation.
Yes. You assume it's linear until it tells you otherwise, like m is proportional to the square root of w. So I've got the square root of w, but the proportional thing is still the k.
Yeah, you just write the k.
So m equals k times the square root of w. The rate of p with respect to t is proportional to p. So let's get the last part of this. Proportional would be k, p would be p. But what is this rate of p with respect to t?
dp dt?
dp dt. So we just wrote a differential equation. In the above equation, can you solve for p? Yes, and it wouldn't be, that doesn't mean solve for p like divide by k to get p by itself. It would mean integrate both sides. And so you'd have p on this side, and yeah, it'd be a little bit more work. The steps: separate, integrate, and then whatever the last word was, meaning use the initial condition if there is one. This one doesn't have one, so it would just be separate and integrate, and you'd have a plus c somewhere.
Plus c or plus e?
Pardon?
My brain isn't. You said plus c, right?
Plus c.
Okay.
1 over p dp equals k dt. So natural log of p equals kt plus c.
My brain just thought you said.
Then you would do the e stuff and the c, the magic c trick stuff. We'll do more of that in a minute. That's the stuff that we, in theory, know how to do.
But we've slept
But
since then.
the new stuff is list 1 through 5 of just like writing our own equation given some information. Number 1, water evaporates from a puddle at a rate proportional to the square root of the amount of water present. Write a differential equation describing the rate of change. So water evaporates from a puddle at a rate proportional. So at a rate proportional to the amount of water present.
Square root of the amount of water present.
So what? Yes. So square root. What do we want to use for the amount of water present? We need a variable for that.
W sub P.
So, okay, I'm open to either one of those. W for water or V for volume.
W.
Volume.
Either one, you get to pick.
You only take W. Yeah.
So let's let W of T equal amount of water. But if you were thinking V as in volume, that's fine too. So the rate of change is dW dt equals K times the square root of W. And maybe this goes unsaid, but there's a lot of things in nature that follow this rule. Basically, the more you have of something, the faster it grows. The more you have of something, the faster it grows. Number 2, the number of giraffes in a large preserve increases at a rate proportional to the 10th root of the population. Okay. G for the number of giraffes.
So G of T.
Okay. I like what we're doing by defining our variables, because otherwise it's hard to get started. Yeah, you don't know what to use, but we're looking for giraffes. So the number of giraffes increases at a rate, dg dt, proportional to the 10th root of the population. Well, the population is the number of giraffes. It's like trying to throw us off by using different words here. So the 10th root, that's kind of a weird one, but it's a good one to practice on. Number 3, air is leaking from a tire at a rate proportional to the amount of air in the tire. Write a differential equation describing the rate of change. So what variable do you want to use? Oh, you switched to A. I thought you were going to suggest V again. A is fine. A equals amount of air. They didn't tell us like if we're measuring volume or mass, so we don't really know. A is the amount of air. So dA dt is, let's see, proportional to the amount of air in the tire. Oh, no square roots, no weird roots, no nothing, just Ka. Why don't you try the next two? So hopefully pretty straightforward on translating the words into an equation. The keywords you're looking for are rate and proportional, and then, is it cube root or is it just proportional to some variable? Just read carefully. I don't think those are too difficult. But you might recognize that's basically where we started the problems before we left. So now we've sort of added a precursor to the problem. Now we'll pick up from there and go the rest of the way. So number 6. In fact, number 6 I think uses that same equation we just wrote. A population of frogs increases at a rate proportional to the cube root. I'm going to write it as f to the 1/3. That way when it comes time to integrate, right? I don't integrate roots, I integrate powers. if the population changes from 27 frogs to 216 frogs in 1 year, what is the population of frogs at the end of 5 years? So I think this means that gives us 2 points. So you could write that as an ordered pair. I'm going to kind of write it as a table. I like writing it as a table because it usually uses more information, and so this keeps my information organized rather than having ordered pairs kind of all over the place. So in year 0, or at time 0, we had 27 frogs. After 1 year, there were 216 frogs. And we may as well keep going with this table idea. What is the population of the frogs at the end of 5 years? So they gave me 2 pieces of information and asked me for the third. Previously, they would always give me 1 piece of information. Now they've given me 2 pieces of information. Do you know why that is?
Because we'll need to verify, I guess.
They're not verifying.
It's easier one way than the other.
We'll just see why in a minute. So let's separate, then integrate. So I need f to the negative 1/3 on the left with df, and then k dt on the right. And then we can integrate. That's the separate step. Then we'll integrate power rule. So increase the power by 1. Negative 1/3 plus 1 is 2/3. My fraction experts. Plus t, but I'm going to put the plus t on the other side.
Plus C?
Yeah, plus c. Thank you. What's the antiderivative of k dt?
KT?
Kt. Good. Good. No one said k squared over 2, because we're not antiderivating with k, we're antiderivatizing with t. And k, they already said k is a constant, so we could have slid k out. Kt plus c. I'll ask the question again. Now do you see why they gave me 2 pieces of information?
Yes.
Why'd they give me 2 pieces of information?
Wait, hold up. For F isn't supposed to be.
Oh, I left off. Yeah. Thank you.
Because I saw it and I was like, pardon?
Yeah, I increased the power by 1 and got so focused on adding fractions I forgot the calculus part.
Algebra is easy, calculus.
Well, no,
You know what I mean.
So they gave me 2 pieces of information because now I have 2 constants to solve for. And basically, you don't intend to set out to solve for a specific constant first. You basically use the easier information first and just see what happens. Because usually one of these things is easy to solve for, and then the other is a little bit harder, but after you found one of them, it's not too bad. Let's see. I think I want to solve for f first. Yeah. This is always like, when do you want to solve for k? When do you want to solve for c? I think I want to solve for f first. So f to the 2/3 is 2/3 kt plus c. And then I hope I'm not making this worse than it needs to be. I'm going to raise both sides to the 3/2. But I've got to raise it all to the 3/2. So now I've got f by itself. I've solved for f, although I still got k and c to figure out what's going on in there.
Alrighty.
So, well, I think it's obvious. Which point would you like to use first?
0.27.
Probably the 0 one. So again, don't set out to solve for K or C. Use the easier point and then just see what happens. So 27 in for F. I got a mess on the other side, but
If there's a 0.
there's a 0 in there, so that's helpful. So K is gone. 27 equals 2/3 C to the 3/2. So let's raise both sides to the 2/3. Ugh, 2/3 everywhere. We got to be careful about fractions and coefficients. 27 to the 2/3.
9.
Power root. So cube root of 27 is 3. 3 squared is 9. And that means C is equal to 27 over 2.
Would it just been easier to not multiply each side by the 3/2 in the first place and just keep the...
Probably. I'm realizing that now. You mean, so your question, Mia's question is,
skip that step.
like, don't solve for F yet, jump back to here, use this,
Yeah.
solve for K and C, and then solve for F at the very end.
Yeah.
Yep. But are we too far into this problem to worry about that?
Maybe.
It's like, maybe, or maybe you think this is awful. Let's go back and start over and do it right here. And it kind of just depends on the problem as to where you want to solve for K and C. So like you could have taken any of these to solve for K or C. So you like I solved for F first as my zeal to get my algebra done. But looking back, maybe this would have been better. Possibly even this one would be better, depending on what the numbers were. I don't know if this one would have worked well or not. Well, I've got C, so I guess we can split the difference here at the risk of being confusing. Let's use that one then for the next one. So F to the 2/3 is 2/3 KT plus 27/2. Is that okay? Do y'all see what I did?
Mm-hmm.
At Mia's suggestion, probably a good one. Because we realized that this was kind of complicated. If we would back up one, things might be easier. All right, so let's now use, so we know what C is, let's now use the other condition, the other point. 216 to the 2/3. It'd sure be nice if 216 was a perfect cube.
I think it is.
It is. K times 1 plus 27/2. I think 6 cubed is 216. So the cube root of 216 is 6. 6 squared is 36. So it wasn't terrible after all. I'm trying to think which way is the best algebra situation. Do you want to add K and 27 over 2, or do you want to distribute the 2/3? I know my answer. And I would distribute because 2/3 and 27/2 is going to work out nicely. The 2's cancel. 27 over 3 is 9. So 27 equals 2/3 K. So K equals 27 times 3 is 81 over 2. Yeah, 81 over 2. So my frogs is, and I bet this will simplify, 2/3 81 over 2t plus 27 over 2.
It's a lot of fractions.
It's a lot of fractions, but look what happens. This was a rigged problem. The 2's cancel. 81 over 3 reduces. 27t plus 9 all to the 3/2. So that was ugly initially, but it sort of worked out in the end. I should be careful here. I'm not boxing that as my final answer. I'm boxing it as that's an important step. So what do I do to answer this final question?
You have to plug in T5.
Yeah, I need to plug in 5 for t. So f of 5. I'm also sensing a safe stop in my near future. 27 times 5 plus 9 to the 3/2. I don't know what that is. Don't care to know what that is. Well, except that I kind of do, because I want to see if my answer makes sense. It should be, I don't know, significantly bigger than 216.
Well, I can figure that out.
27 times 5 plus 9. 144, that's a convenient number to raise to the 3/2.
1728.
1728.
That's a lot of frogs.
That's a lot of frogs, that's right.
It's like that one TikTok guy with the army of frogs. His neighbors literally moved away because of all the frogs.
Number 7. Number 7. And we'll stop it after this one. A bacteria culture starts with 500 bacteria. Starts with 500. What's that mean?
0, 500.
Yeah, T and what letter do we want to use? B for bacteria. So 0, 500.
A lot of bacteria.
Grows at a rate proportional to its size. So dB dt at a rate K times its size. Well, its size is the number of bacteria, so KB.
And it gives us a second place.
After 3 hours, there are 8,000 bacteria. Find an expression for the number of bacteria after T hours. So that means what we want is B of T. Right, so this statement isn't enough. I mean, it's correct, but it's not what it's asking
Get
for.
you a singular point, maybe.
So it might get you a point, because that would be the first thing you'd have to do. Okay, separate and integrate. dB over B equals K dt. And I don't know if I said this, but almost always on the free response questions, you get a point for separating the variables. So it's like, yeah, I just got pretty much a free point. Even if I forget how to integrate those or things go haywire from here, I got a point. dB over B equals K dt. Separate and integrate. Okay, now let's integrate. Hopefully this one isn't too bad. Antiderivative of dB over B?
LNB. Right?
Yes. Ln natural log of B equals KT plus C. Letters flying all over the place. T and B are the variables. K and C are the constants. Right? So you got to be careful here. This information over here will help me find K and C in a moment. But this is the... So that's supposed to be absolute value bars. This is the loop-de-loop thing. To rewrite it as B equals. So e to the kt plus c equals b.
Yeah. Well, C2 times KT, e to the KT.
Yeah, so b equals different c, e to the kt.
Just mark it differently.
And yeah, I like to mark this one as the different one. That way I don't have to write C2 a bunch of times.
To me, it keeps it chronological.
You're right. It does make more sense to go in order. But then you got to hold on to your C2 the rest of the problem.
Makes it easier to backtrack.
Okay. Yeah, there's two unknowns in this that I'm looking for, and I've got two pieces of information.
Well, let's go with the 0.
Let's go with the 0 first. Right? And initially, you don't know what leads to what. After you've done a bunch of these, you know what you're going to find first, just because it always works that way. But initially, just use the easiest one first. 500 in for B. C e to the k times 0.
So,
Oh, that's lovely right there.
C2 equals 500.
So C equals 500. Alright, so that told us what C is. So now B equals 500 e to the kt. And now we can use our other piece of information.
Which is just lovely.
This one doesn't look like it'll be quite as much fun. $8,000 equals 500 e to the k times 3. Now I have to solve for k.
Yeah.
Yeah, is right. I can divide both sides by 100. Mark out the zeros. The easy stuff first. What about 80 divided by 5?
8. No. 5 times 8 is 40.
So 5 times 16 is 80.
Yeah.
So
I was getting there.
you were getting there. So e to the 3k equals 16.
ln.
Yep. Natural log both sides. Because
You gotta get rid of that e.
that will fix the natural log e and bring the 3k down front. Sorry.
ln 3 ln 16 equals k.
1/3 ln 16 or ln 16 over 3.
What did I say?
I think you said 3 ln 16.
Oh. It's Monday.
So my equation then, my expression for B, back up here, C was 500. E to the, I'm not going to write all that, I'm just going to write KT because I've said what K is. I've defined K, so I don't need to keep writing it again. That might be a good thing. If this is a calculator problem, which it probably is, I would probably store that in my calculator as K, and that way the rest of the time I need it. In fact, I'm going to do that right now. Grab a calculator. Natural log 16 divided by 3.
Store alpha k.
And store that as K. That way, I'm good with that from now on. I don't have to worry about. I don't have to write out 0.924. I don't have to write natural log 16 over 3. I can just write K, and I've told the grader what K is, and I've got it in my calculator, so I'm just using K from here on out. How many bacteria are present at the 4-hour mark? So, in terms of my table over here, where's 4 going? T. So when T is 4, find B. So B of 4 is 500 e to the k times 4. So this is like, that's the easiest part of this problem, because I can just put that in the calculator. 500 e to the, go get k, times 4. And that's enough work to show, because you've defined what k is, and the rest is in the calculator. So 20,158. It didn't say round to the nearest bacteria, so I guess we should put 3 decimals. That's a little bit weird, because you can't have a 0.7 of a bacteria. On problems like this, the
One's in the middle of mitosis.
The AP test will usually say to the nearest person or to the nearest bacteria. To avoid that, what do I do with 0.4 of a person? Do I round that person up, or what kind of, human rights does a 0.4 person have? What's going
Let's
on?
not.
We don't want to go down that road. So they would usually say to the nearest person, or maybe to the nearest bacteria. When will the bacteria reach 30,000? So I'm going to write the equation down. So that means 30,000 is B equals 500 e to the kt. Now, how you solve that is up to you. You could graph it, but I wouldn't want to graph it, because your window would have to go up to 30,000. What you can do is just...
You could just set another as y equals 30,000.
Yep, and find the intersection. I'm going to do this a little bit more algebraically initially. Like, I'm at least going to divide by 500 to give me easier numbers to work with. So 60 equals e to the kt. Now, if you want to graph that, and graph e to the kt and graph 60 and see where they intersect, that's fine. I think I'm going to keep going with an algebra approach and natural log both sides. We've already used natural log and e 3 or 4 times, so it started out really ugly, but it reduced to natural log of 60 over k. I guess that's still kind of ugly, because k itself is ugly.
But so you could just plug it in the calculator.
But I've got k in the calculator, so natural log 60 divided by k. .430 hours. I didn't do this on the table. I wish I should have. I'm going to put it in now, because if you put all of your data in one spot, it's easy to kind of check your answers to see if things are making sense. So like the last point was, when is it 30,000? And so it's like, well, it's got to be more than 4, but not a whole lot more than 4.
Yeah.
Because this thing is growing exponentially, so we're not a whole lot more than 4. And I got 4.43, so that kind of makes sense. So I think holding your information in a table is helpful when you get to the end, because you can see that it all works together. All right, your assignment today is 1, 2, 7, and 8 on worksheet 3.
You got it.
1, 2, 7, and 8. And then tomorrow we'll work those last 2 examples, although there's nothing new with them. Well, they're just algebra. So our next test is next Monday and Tuesday. And by the way, Monday is no calculator. Tuesday is with calculator. And then there's one more real test, and then the rest is AP review.
So you're not taking the AP test?
You're still going to do all the stuff.
Okay, there's still grades?
Yeah.
Oh, okay.
Because there's grades, and one of the AP tests would be a grade. And
Okay, so I still take the AP test?
you don't have to take the AP test. It's just you got to do all preparation for the AP test.
No, I didn't have the degree right now. So, I'll double check.
Never drink water. What's that?
All right, guys, let's back away from the door and close the door because we still got 7 minutes. So nobody needs to.
Over there.
Nobody needs to make a run for it.
Preston, although I know you wanna, don't drink water for too long.
Was that it? Don't drink water. I thought it was something else.
I don't think I would have. It doesn't sound like a good idea.
You're still recording.
Oh, I sure am.
Oh, that's